So here we have to find all the points of discontinuity of f, where f is defined by f of x equal to x cube plus x cube minus 3 if x is less than or equal to 2, and x squared plus 1 if x is greater than 2. So this is question number 11, and this is question number 12. So first, let us solve the 11th one. So here, as we know that all polynomial functions are continuous. Here in both the questions, we have to use the rule that all polynomial functions are continuous in their domain. All polynomial functions are continuous in their domain. So it means that for x less than or equal to 2, x cube minus 3, it is a cubic polynomial. So it is a continuous function. So now, therefore, we have to check only where the definition changes. So therefore, at x equal to 2, we have to check. So now the left hand limit will be equal to limit x tends to 2 minus f of x. That will be equal to limit h tends to 0 f of 2 minus h. So that would be equal to limit h tends to 0. So in place of x, so I have to put 2 minus h. So that will be 2 minus h whole cube minus 3. So that will be 2 cube. I can put h equal to 0 here. So that is 2 cube minus 3, that is 5. And then the right hand limit, that will be equal to limit h x tends to 2 plus f of x. That will be equal to limit h tends to 0 f of 2 plus h. So when it is slightly more than 2. So if it is slightly more than 2, we have to put x as 2 plus h here. So this will be limit h tends to 0, 2 plus h whole square plus 1. So that will, so here I can put h equal to 0 here. So this will be 2 square 4 plus 1, this is 5. And f of 2, that will be also 2 cube minus 3, that is also equal to 5. Okay. So hence, in this function, there is no point of discontinuity. So I can say there is no point of discontinuity in this function. And in the question number 12 here, here also for x less than or equal to 1, x is a, the function is a polynomial of degree 10, and for x greater than 1, it is a quadratic polynomial. So it will be continuous at for all values of x greater than 1 and for x less than 1. So we need to check the continuity of the function only at x equal to 1. So therefore, at x equal to 1, we need to check the if it is continuous or not. So therefore, the left hand limit we have to find, that is limit sorry, so that will be limit x tends to 1 minus f of x. It means when it is slightly less than 1. So then it is limit h tends to 0 f of 1 minus h. So that will be limit h tends to 0. In place of x, I will put 1 minus h. So that will be 1 minus h whole power 10 minus 1. So here I can put h equal to 0 here. So this will be 1 power 10 minus 1, which is 1 minus 1, that is equal to 0. And then we need to find the right hand limit, that is equal to limit x tends to 1 plus f of x. So that will be equal to limit h tends to 0 f of 1 plus h. So we have to put h equal to 0 here. So it will be limit h tends to 0, 1 plus h whole square, that is. So we can put h equal to 0 here, that will be 1 square, that is 1. And the value of f of 1, that is also 1 power 10 minus 1, that is also 0. So now therefore the limit here, you can see that left hand limit is 0, the right hand limit is 1. Therefore I can say limit x tends to 1, f of x does not exist. Does not exist. So the function is not continuous at x equal to 1. So therefore I can say, so the only point of discontinuity, so the only point of discontinuity of this function, only point of discontinuity of the function f of x is at x equal to 1. So this is the answer. So hope you have understood how to check, how to find the points of discontinuity of a function. Thank you.